Hello. This video was created to provide a little bit more information and background on the Future Forward project, Regenerative Braking Systems, which is intended for the transportation technology sector. Although regenerative braking has become a lot more prevalent in the last several years with its use in electric vehicles and hybrid vehicles, it's actually a concept that's been around since about 1886. It wasn't until 1997 where we actually saw it being included in production vehicles, and since then it's been tweaked to provide the maximum amount of efficiency, which enable electric vehicles and hybrids, better fuel efficiency, longer distance driving on a single charge, and a little bit less wear on the conventional braking components. The project itself is intended to show the students the idea behind regenerative braking and some of the components and processes involved, so that when they experience it down the road, they'll be a little bit more familiar and comfortable with the system and how it works. The project itself is built into 3 sections. The first 2 sections are lessons, which could be completed in about 2 days. The first one really keys in on the idea of the law of conservation of energy and in conventional braking, how the energy is converted from the kinetic energy of the vehicle into thermal energy through friction in conventional braking. Most of that energy is lost to thermal energy, whereas in regenerative braking systems, it is able to recover some of this energy and turn it into electrical energy instead, which it reintroduces back into the system to help charge the vehicle. So some of the ideas behind the regenerative braking systems that will be either reviewed or introduced to the students are the law of conservation of energy, electromagnetic induction, such as that we see in alternators, and a little bit of wiring and basic circuitry. The second part of the project lesson deals with focus on the mining sector. The reason we chose the mining sector is to show the students that regenerative braking isn't just a system that's used in the automotive sector. It's used across a lot of different industrial sections as well. The reason being that a lot of these companies are aiming to go net zero emissions and are turning to electric vehicles over the traditional internal combustion engine vehicles, and are therefore implementing a lot more regenerative braking systems and kinetic energy recovery systems into their vehicles in order to increase the efficiency. The mining sector is such an important sector in Ontario, and they've had a lot of mandates recently that are sort of coercing them into switching to the electric vehicles section, including a mandate which states on September 1st, 2023, particulate emissions in mines have to be reduced by 70%. A lot of these particulate emissions are caused by traditional internal combustion engines, and therefore the use of electric mining vehicles have become a lot more popular. In the mining section, there's a lot more use for regenerative braking due to the steep pitch that these vehicles are going down and the heavier loads, which enable them to create a lot more kinetic energy, which in turn creates a lot more recovered electrical energy. So the second part, McLean Engineering, which is based out of Collingwood, Ontario, has provided some slides which show their production of electric vehicles intended for the mining operations. They are able to provide any traditional diesel mining vehicle or piece of equipment in the electrical version. So these slides include some of the stats and facts on the battery, their charging capabilities, the philosophy times, and the benefits of regenerative braking systems in these mining vehicles in allowing their vehicles to run for longer times. It's going to reduce a lot of the emissions in the underground sections of the mines. And in some instances, they're experimenting with the fact that they create so much energy from this reclamation process that they can integrate it back into their subsystems and use that electrical energy not only in their vehicles, but for other sections such as ventilation, lighting, etc. The third part of the project is the build itself. A lot of the materials that are recommended in the build and the measurements are more guidelines. This is a section where the students can really flex their creativity in the model or body or shape of their vehicle. The idea being that it's familiarizing themselves with the idea of how electric motors can be both drivers and driven, which change them into generators to create this electrical recovery system. So the idea and the focus is to use 2 electric motors driven by a 9-volt battery. It is recommended to use the 9-volt as opposed to some of the DC motors that come with AA batteries, because 9-volt provides a higher voltage, which is needed to both drive the vehicle and provide energy to power and illuminate the LED lights, which are going to be wired in. A little bit of previous knowledge that's going to be beneficial to the students is basic soldering techniques, reading wiring diagrams, basic circuitry, understanding polarity, especially when it comes to LEDs or light emitting diodes, and using multimeters to test LEDs, to test polarity, voltage, and current. So once these students take their time to really focus on the proper circuitry, soldering, the polarity and the flow of electrons through the system in order to make the lights work, it's going to benefit them with those skills. For evaluation, we're going to look at the final product. We want to see proper solders to ensure solid connections that allow for the best flow of electrons through the circuit. We want to see the fact that the car is able to be driven by the motor, and it's also going to drive the generator motor, which is going to create enough electricity to power the LEDs. So as the car is driving, the LEDs are going to illuminate and show that it's indeed installed in the proper way and has solid connections. A lot of the materials are easy to source. Any arts and craft stores, I went to some local hobby enthusiasts who provided me with some free electric motors to use in my vehicles, as well as the online option to allow for a little more flexibility in what materials and the type of vehicles that the students are creating. Hope this helps. Good luck and all the best.